In this video, I want to talk about the states of matter and how the difference between states is all about energy. There are four basic states of matter: solids, liquids, gases, and plasma. Each state has its own basic characteristics. Solids retain a fixed volume and shape. The particles tend to be rigid with low energy. They're not easily compressible because there's not much space between the particles. They don't flow easily, and they can't slide past one another. Be prepared to describe the state of matter shown here in terms of its energy and general physical characteristics. Liquids can be described as having medium energy. Their particles easily flow past one another, but there isn't much space between particles, so liquid particles are not easily compressible, but they do assume the shape of the container they're held in. Be prepared to describe the energy of these molecules and how they're moving in relation to each other. Gases have a lot of space between particles since they move with such high energy and are so easily compressible. Gases take the shape of whatever container they're held in. Why do you think this is so? Be prepared to explain why gases will take the shape of any container they're held in. Plasma is a very high energy ionized gas. It has so much energy that electrons have been removed from their atoms, resulting in positive ions and free electrons. Plasma is the most common state of matter in the universe. It describes the sort of high energy that stars exist in, but it's rather unstable on Earth. I wouldn't be surprised if the next quiz asks you to describe what each of these illustrations is showing you in terms of energy. As you can see, the difference between states of matter is the amount of energy and how the particles behave towards each other. As energy is added or removed from particles, they'll change from one state to another. Each of these changes in energy cause a phase change to occur. When energy is added, particles will move more and will move farther away from each other. Low energy solid particles will move away from each other. We refer to this as melting. Ice will become water. If enough energy is added to water, then water particles will be able to break free of their bonds and become gas. We refer to this as vaporization. Liquid water becomes water vapor or gas. When solids gain enough energy, they melt, and if they gain even more energy, they can vaporize to gas. It is possible for solids to go straight to the gas state. This is called sublimation. If you've ever seen an empty ice cube tray, you may have found it after the ice sublimated from ice to water vapor in your freezer. Or you might have just found the ice cube tray after your little brother took the last ice cube out and just didn't refill it. If energy is removed from gas, it can condense to liquid, like water vapor condenses on the side of your glass. If enough energy is removed, the liquid water may freeze. Another way to describe freezing is solidification. Sometimes gas can go straight to solid, like water vapor crystallizing on your window in the winter. This is called subluxation. Believe it or not, sweating is a cooling process. How do you think this is true? Study these diagrams and the previous diagrams, and be ready for a quiz on phase changes. Keep in mind that energy cannot be created or destroyed, but it can be transferred. If energy is added to anything, it has to come from somewhere, and that somewhere will have less energy now. When we refer to the amount of energy that's needed to change matter or alter its state, we're talking about its specific heat capacity, and latent heat. By definition, this refers to the amount of energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Every substance has a melting point, a freezing point, and a vaporization point. If enough energy is added to a substance, it will melt or vaporize. If enough energy is removed, it'll freeze. We often use water as an example since everyone is familiar with water in all three of its states. We all know that water is made of oxygen bonded to hydrogen atoms, and they're happy together. They make a tight bond, so a lot of thermal energy is required to break those hydrogen bonds. This is why water holds on to its temperature longer than most other substances. Increased energy between the molecules will cause them to move around more, resulting in an increased temperature, but the bonds will not break. By adding energy, molecules will move farther away from each other, but it'll take a lot of energy for them to overcome their bonds entirely, so they'll break from other water molecules and vaporize. But only about 20% of the hydrogen atoms will actually break free of their hydrogen bonds. The amount of energy and heat released or absorbed during these phase changes is called latent heat. Water has a very high latent heat. In other words, water can absorb a lot of energy before changing its phase, but holds on to its energy once it's absorbed it. Have you ever noticed the ocean feels cold even when you go to the beach on the hottest day in July, but it's warm if you go in on Labor Day weekend? It takes all summer for the ocean to absorb enough energy to notice a temperature change, but then you have to go back to school and you don't get to go to the beach anymore to enjoy it. The seashore is generally warmer during the winter months than we are farther inland because of the energy from the ocean water being given off all winter to the air. The air at the shore is warmer in the winter but feels cooler in the summer because it's absorbing energy from the air all summer. Latent heat refers to how much energy is required to raise 1 gram of substance 1 degree Celsius. It takes 80 calories of heat to be released from water to make it freeze, or 80 calories added to ice to make it melt. On the other hand, it takes 600 calories to make the water vaporize. Check out this video as a great review of the states of matter and energy required to effect a change of phase.